Hi, this is Ramachandran from onlinemathforall.com. This video is about problems on limits and continuity. Here we are going to have a problem on limits. So the question we have on the board is evaluate limit x tends to infinity to x positive 1 over x to the power 3 positive 1. Okay, so this is a problem with the limit infinity. So the variable we have in this problem is x. So now I am going to apply the limit infinity for x in the given function. When I do so, I will be getting 2 times infinity positive 1 and infinity to the power 3 positive 1. So 2 times infinity will be infinity. Infinity positive 1 will also be an infinity, because if you add or subtract any value to infinity, it will also become infinity, and if infinity is multiplied by any value, so the answer will be infinity. So the denominator also, the if you take any power for infinity, so that will also become infinity, and when we add 1 to the infinity, again the value will become infinity. So infinity over infinity. So this term is called indeterminate form. So whenever we get results like infinity over infinity, so this is called indeterminate form. So when students get this kind of results like indeterminate form, they may think the problems in which we have the limit is infinity is difficult to be solved, because we have a limit infinity. When even when we apply the limit infinity for x, we get the result like infinity over infinity. So it's a bit difficult to get the right answer for this kind of questions, particularly in which we have the limit infinity for the given variable x. But the thing is not like that. So this one also can be easily solved once we know the trick. I'll show you the trick that we are going to apply in this particular problem, particularly when we have the limit infinity for x and also the given function is rational. I'll show you here. Please give me a moment. So here, when we tried first time to solve this problem, I just applied infinity for x in the given rational function. So the numerator 2 times x, instead of x I just took the limit infinity, and also the denominator in x cube I just took infinity for x. I just did everything. But before we do the step, before we apply the limit infinity for x, we have to do one important thing in this kind of function, particularly in rational function. So the first thing what we have to do is we have to find the term x with highest exponent in the rational function. In this rational function, we just have to find the variable with highest exponent. So whether it's going to be the numerator or denominator, it's not a problem at all. We just have to find x. It can be either the numerator or denominator. So when we are trying to find the variable x with highest exponent, so we find x cube. This is a term of x with highest exponent. We have this one at the denominator. So now the first thing what we have to do is, before we apply the limit, the first thing what we have to do is, in the given rational function 2x positive 1 over x cube positive 1, both numerator and denominator to be divided by the variable x with highest exponent. So in our problem we have x cube. So here both numerator and denominator to be divided by x cube. So here students may have a question. In this particular problem we divide by x cube. So what do you have to do in other problems in which we have the limit infinity and rational function? The same thing we have to do. That is, we just have to find the variable with highest exponent, and then we have to divide both numerator and denominator by that particular term. So in our problem we find the variable x with 3. So that is a variable x, that is a variable with highest exponent. So now I am going to divide both numerator and denominator by x cube. So I'll show you in the next step. So limit x tends to infinity. Now I divide the numerator by x cube, then denominator by x cube. Now I am going to take this x cube denominator separately for 2x, separately for 1, and the same thing I'm going to do here. That is, I'm going to take this denominator x cube separately for this x cube, this one. So when I do so, I'll be getting limit x tends to infinity 2x over x cube positive 1 over x cube sorry, 1 second. So here I've taken x cube a denominator separately for 2x, separately for 1 here, and also the same thing I have done at the denominator x cube positive 1 over x cube. So now this x and cube will get cancelled and it will become 2, and here x cube will get cancelled, so we'll have 1 here, 1 over 1, it will become 1. I'll just proceed the next step on the next page. So here, so please give me a moment. So limit, so 2 over, sorry, limit x tends to infinity 2 over x square positive 1 over x cube divided by 1 positive 1 over x cube. So we can't do any more simplification because I already have done simplification work on our previous page. So because we just add here 2x over x cube, x and x cube are simplified, we get 2 over x cube x square. So now I am going to apply the limit infinity. So when I do so, 2 over infinity square will be infinity, 1 over infinity cube will be infinity, 1 positive 1 over infinity cube will be infinity, and any number is divided by infinity will be 0 over 1 positive 0. So we get 0 positive 0 will be 0, 1 non-positive 0 will be 1, 0 by any non-zero number is equal to 0. So the answer for the given problem, limit x tends to infinity 2x positive 1 over x cube positive 1 is equal to 0. As soon as the problem, this kind of limit problem is seen by the students may think solving this kind of problems is a bit difficult because we have the limit infinity. 1 second. Because we have the limit infinity, and also even when we apply the limit infinity in the given rational function, we get the result infinity over infinity, that is indeterminate form. So we are not able to get the right answer. In this way the students may think, but the only trick what we have to apply in this problem is, in the given rational function we just have to find the variable with the highest exponent, and then we have to divide both numerator and denominator by that particular term, that is the variable with the highest exponent. So in our problem we find such a term, that is x to the power 3. So there we have highest power for x, so I just divide both numerator and denominator by x cube. So this is the only trick we just do in this, we are applying this problem, and then we divide both numerator and denominator by x cube. After doing simplification work, again we apply the limit x tends to infinity. So when I apply x tends to infinity, after having done the simplification process, I get the value 0. So the value of the given limit is 0. I hope the students will be able to understand how to do this kind of problems easily. Okay students, for more videos like this, please visit www.onlinemathforall.com. Thank you.